Okay, so our agenda today, we're going to be talking about rationality and whether your brain is capable of it and when. And the reading that this is a companion for is completely focused on psychology, but I'm going to be bringing in some philosophy as well. And because this is, at least theoretically, the first reading that is going to combine philosophy and psychology that you have encountered, or at least the first lecture that's going to combine those two things, I'm going to have a little bit to say about what the difference is between the two disciplines, just so you have a kind of an idea and can see in our approach to rationality here how each discipline can bring its own variety of insight, and we can combine those to have a better appreciation for what rationality is and what irrationality is, and when and in what circumstances we might be capable of it. So the first thing that I want to talk about here is to contrast science with philosophy. In this course, it's a critical thinking and logic course. This is a fairly specific sub-discipline of philosophy, and so you don't really get a good taste in this course about what philosophy in general is all about. In the same way as if you took a microbiology course as your first and only science course, you might not understand what it is that makes science because things are really specific in that particular subfield. So I thought it would be good to kind of just contrast at a kind of a 30,000 foot level. What is it about philosophy that makes it different from science? What's characteristic of science? And then also, as we kind of zoom in to compare it to psychology, get a better understanding of what's going on here. So in general, the key thing that distinguishes the sciences from other areas of inquiry, from other academic scholarly pursuits, is that the sciences are characteristically at base what we call empirical. That's a fancy word for based on observation and especially experimentation. And the sciences use observation and systematic observation. That's what experiments are, systematic controlled observations, to account for, predict, perhaps explain observable phenomena. That all hopefully sounds utterly unsurprising and non-controversial to you. Like, post comments if that seems at odds to your image of the sciences in general. Pick a science that you think doesn't meet that, and comment about it in the comments if you think there is one. In contrast, other areas of inquiry, like that's what the sciences do. And so sometimes, and because the sciences have been, in the short history that they have been alive, the last 400-ish or so years, they've been enormously successful in generating a ton of knowledge about the world for us. And so sometimes we will kind of use the standard, the methodology, the fundamental approach of the sciences. We'll say, well, everybody's got to do that. Look at how well it works out for the sciences, right? Why can't English Lit do this and change from, whatever it is that it's doing right now? And, why can't philosophy do this? It's been around for 2,000 years and they haven't solved anything, goes the story, which is actually not very accurate. But anyways, we're gonna set that aside. But the idea is, why can't you do this more sciencey? Whatever it is that you're doing, why can't you do it more sciencey? Why can't you go about it in the way that the sciences do? Because obviously the sciences are way more productive at discovering things about the world. Why can't you do that? And the reason is because the subject matter admits of that. That's what they're aiming for, so it's no surprise that the methods that they use match the kinds of information that it is that they're after in the sciences. The sciences are looking to account for and predict observable phenomena, so of course they gotta look at observable phenomena. They gotta look at it carefully and systematically, and that's why they use experiments. They fit together. The method fits the thing that you're looking out for. Philosophy is, in contrast, an entirely different kind of thing. It's looking for entirely different kinds of knowledge about the world. Philosophy's method and target is primarily conceptual. Okay? So what that means is philosophy is engaged in understanding concepts and meaning. Of concepts, not of words. Though we use words to communicate concepts, philosophy is this is at least one way to capture what philosophy is all about. Philosophy is about understanding concepts, coming to a better, a more precise and accurate understanding of the concepts that we use every day, or in particular specialist situations like in the sciences, and learning to understand them more precisely, because we use concepts really casually in everyday discussion and thinking, and sometimes that can get you into a lot of trouble in an analogous way to conducting a scientific experiment really casually and without very much attention to detail, right? If you've ever taken a lab course, you know that there's lots of kinds of insanely specific procedures that one must follow, and if you've learned a little bit about science, you know why those things happen, right? You got to wash out every beaker really well. You've got to make sure that your instruments are calibrated every time you run an experiment, because if they're not, then you can't trust the results. And so philosophy does the same thing. It says, look, we use concepts every day, sometimes really highly technical and precise ways, but if the concepts that we use are imprecise, vague, or contain internal contradictions, or get used or are importantly different when deployed in one area of thinking as opposed to another, then we need to figure that stuff out. We need to nail it down. We need to make them precise so that we can use these tools precisely, because if we don't, then any thinking that relies on those tools that have been not refined, not calibrated, is going to be off. We're going to reach suspiciously wrong conclusions. Okay? Now, if you're studying concepts, then you can't use observation and experiment. You have to use other methods. You have to use reasoning, reflection, perhaps, and this is controversial, intuitions about concepts to help explore them, to help critique them, to help refine them. So that's the main difference between the sciences and philosophy. All right? Now, another way to put this, which is even kind of more rougher, but it like fits on a bumper sticker, is that science investigates the is of the world, the actual things out there, where philosophy investigates the ought, or the ideal, the kinds of things, those concepts that we use to interact with and understand the world are often idealizations of real world stuff, right? And so one way to kind of capture the distinct difference between the sciences and philosophy is that science investigates the actual and philosophy investigates the ideal. What does this mean for rationality? Well, it means that when both fields, psychology and philosophy, look at this area of nature, at rational behavior, at rationality, what counts as rationality, psychology explores the is. It explores what is or behaves rationally under what circumstances. Now, if you don't have a good idea about what this word means, that is, if you don't have a good idea of what the concept of rationality actually means, it's going to be pretty difficult for you to go out into nature with your measuring instruments, whatever they are, and observe it, right? So before psychology can really get started on firm ground and go out and propose experiments and run experiments and collect data and massage the data and come up with results, it needs to know what it's looking for and what it's not looking for. And that's where philosophy steps in. Philosophy explores what rational means, and also, perhaps, when and where we ought to be rational. That's a kind of a side issue, but it's something that philosophy also worries about, and it's something that we're going to see a little in a few slides. Okay, so that's the distinction between a psychological exploration or investigation of rationality and a philosophical exploration of rationality. And in some sense, the philosophical exploration has to reach some degree of success first before you can even get started with the psychological exploration. Because if you don't know what you're looking for, then you can't go looking for it. Okay. So here's what this reading tells us about rationality. So this is my kind of quick review, right? Two systems of thinking, System 1, that is the subconscious, the automatic reptilian brain kind of thing that is really reactive and quick to think, and is operating all the time, but almost all the time, below the level of our conscious awareness. It's doing all the housekeeping work. It's doing all sorts of other things that 99.9% of the time we aren't aware of. System 2, in contrast, is the part of our brain that is doing all of the executive functioning, right? They're the person at the top, right? One of the analogies that we can use, though it can be really inaccurate and misleading, right, is that we're a whole office building, our brain is a whole office building, and System 2 is the CEO, and System 1 is all the middle functionaries and all the other folks lower down who actually get all the work done, right? And System 2 just kind of gets reports once in a while and makes some executive decisions. Hey, let's work on this thing, let's work on that thing, and then their job's done, and then these people go off and do it. But lots of stuff happens down below in System 1 that System 2 never gets informed about, unless something goes drastically wrong, and then, emergency reports fly up the chain, and then System 2 becomes aware of it, and then System 2 actively and consciously manages whatever emergency situation it is. Now, my only kind of comment on this is those are terrible names. This is really hard to remember this, and it's really not helpful. And you'll find this sometimes philosophers, especially if they've had a little bit of classical education, can come up with some neato names for what it is they're doing. But if not, or if they kind of pick provisional names as they're working on it by themselves, and then they kind of publish a paper, and then the paper kind of blows up because it's a real kind of thing, then maybe kind of the working titles that they had for the things that they're talking about then become the kind of the normal thing. I don't know exactly what happened with this, whether it was, somebody kind of proudly picked these two names and said, these are good names, System 1 and System 2, or whether they were just kind of accidentally adopted, that someone just kind of, in their notebook, 1 and 2 were, kind of easy to scribble down and write about rather than giving them more descriptive or evocative or creative names, and then kind of it got out of their control once it got dispersed to the wider psychological community, and everybody kind of ran with System 1 and System 2, and they couldn't rebrand. I don't know how it worked, but it's terrible. It's hard to remember which one is which. I would have vastly preferred if they had called System 1 the reactive system, and then System 2 like the executive system or something like that. But in any case, that's kind of how we have to straighten these out. I've had a little bit of familiarity over the years with System 1 and System 2, so I won't trip myself up. I'll 99% of the time use the right number when I'm talking about which kind of mode of thinking we're talking about, but you might find it easily confusing. System 1, that's the lower level, the kind of the reptilian primitive brain that's responsible for subconscious reactions, and System 2 is the neocortex, right? The executive conscious part of your mental activity. Now, here's the thing. In that chapter, he talks a lot about some different exercises. And he invites you to do some. And I don't know how many of you did those things and tried those things out and commented in Perusall about how difficult or easy or how you got tripped up or anything like that. But unbeknownst to you, before you did that reading, I asked you to do something very, very similar, because I wanted to have data that, on you folks specifically, right? So that you could have the legit experience that you read about in the Kahneman chapter. And that was the simple quiz that was part of the orientation module. It was actually for this reading. I didn't want to give it away and say it's for one of these readings because I didn't want to spoil anything. Everybody got 3 types of questions. You got 1 question of each type, though people got different questions with slightly different numbers in them, just so that there was some variety there and stuff. You got questions about cost splittings, you got questions about fillings or rates, and you got questions about time to double a particular thing. And we're going to see how well you did. Okay, so I'm going to revisit. These are the same kinds of questions that you probably got on the quiz, which you've already forgotten about probably, right? So the cost splitting questions look kind of like this. They gave you two objects, in this case a pen and a pencil. They gave you a total cost, and then they told you how much more one thing cost than the other, and then they asked you, simple math problem, how much does the second thing cost, right? And this is probably how you thought about this. Oh, $4.50, pen cost $4, so that means 50 cents left over, so the pencil is worth 50 cents. Turns out that's wrong. That's wrong because this question asked you how much more is the pen than the pencil. It didn't say that the pen cost $4. It said the pen cost $4 more. So that means the 50 cents that you left over at that subtraction has to be split between the pen and the pencil. If the pen is 4 1/4 and the pencil is 1/4, then the total cost is $4.50 and the pen is worth $4 more than the pencil. That's the right answer. Okay, I don't expect that you remember, since your question had different numbers and different objects, you probably don't remember what you were, you probably at most remember, I was thinking, yeah, I thought something like this and it was a pretty easy question, but maybe you don't at all. But anyways, those were the cost splitting type questions. The second type of question was a filling or rate type of question. You got something about it takes so long to fill this. If we change this, how much longer does it take to fill? In this case right here, I've got 8 sewing machines that take 8 minutes to make 8 pairs of jeans. And then I vastly increase the number of sewing machines, but I also vastly increase the workload. If we now have 30 sewing machines, how long does it take to make 30 pairs of jeans? And so, oh, why is that? Yes, there we go. And so you probably, on a question like this, guessed 30 minutes. But it turns out that's not right. You have to ask yourself this question: does each machine work on every pair of jeans? No. With the 888, we've got basically, or we could, right? The sewing machines could divide their labor up any way they kind of liked here, right? But the way that those numbers are, each sewing machine could make one full pair of jeans each, and each sewing machine could take 8 minutes to do it, right? If we have 30 sewing machines, they're going to go through jeans faster, but we have a larger task, right? And so it turns out we've actually kind of matched up still machines with jeans, so 8 minutes is the correct answer, the exact same time to make, because we've increased our capacity at the same time as we've increased the outgoing job task at hand, right? So this is kind of a trick question, especially because it's like 888, and then I kind of prime you with this question with the 3030, almost begging you to fill in the third number with a 30 instead of an 8. The last kind of question, the doubling questions. So here's an example. Every year something doubles in size or doubles in number. If it takes 10 years for this coral die-off to reach 4 million square miles, how long did it take to get to 2 million square miles? And the idea here is that you're maybe thinking this is also deceptively easy in the same kind of way. It's simple math, right? How long does it take to double? You might be tempted to say if it took 10 years to get to 4 million, then to get to half as much, you're going to think, well, 5 years, half as much time is going to get me half as much. But one of the key things that this question talks about right up front, every year it doubles. So you double every year. It's just because we got half here doesn't mean you're going to half that. And so another way to phrase this is, if some mystery year, year X, was at 2 million square miles, how many square miles are going to die off the year after that? And if it's doubling every year, then the answer there is 4 million, which means that the correct answer to this question is 9 years. It's going to take 9 years to get to 2 million, and then the year after that, 10 years, it's going to get to 4 million. Now, all three of these questions and the particular versions of them that you took are definitely kind of tricky questions. Now, they're not loaded with double negatives. They're not some kind of fancy math or anything like that. There is a kind of a trick there, but it's not a trick that's totally out of your mathematical abilities or comes from left field. The trick is that each one of these questions was kind of asked in a familiar way to try and invite your system 1 to supply an answer. And because your system 2 didn't hear any alarm bells from system 1, wasn't particularly challenged by the math questions or detect any kind of importance to what was going on in this quiz, because I think I tried to reassure you right at the start, this is just a survey, so I'm not grading right or wrong, I'm just grading participation, right? That was part of me trying to relax your system 2 and so that it wasn't supervising very well. Most of you probably let system 1 run the show here and answer all those questions without consciously thinking through it. I'm guessing nobody kind of took out pen and paper and did some calculations or anything else like that. And that's why most of you got this wrong. So here are your results. As a class, less than a quarter of you got the cost splitting question right. As a class, about a third of you got the fill rate question right. And a little bit more than a third of you got the doubling questions right. So and if we add those up with other classes that I've done this to, I've got almost 400 students now, and this is everybody's overall performance. And we're talking, you people are intelligent. This might have made you feel dumb, but you're not dumb, right? But you look at the overall performance, 9% of nearly 400 students got all 3, which at the bottom, all 3 of these are very easy mathematical questions. Very easy math. There's no calculus here. There's no geometrical proofs. There's just basic addition and subtraction and stuff like that. But they're word problems, so that's maybe a little bit tricky. And they were phrased exactly to try and trick you to try and exploit the difference between system 1 and system 2. And fully half of you, I don't know what the decimal place is there, but fully half of you got actually 0. You got none of these correct, which is kind of amazing, right? Maybe not in a good way, you're thinking, but nevertheless amazing. Now, there was a 4th question on this test. I asked you how well do you think you did on this test? That was the 4th question. And this is what I only started asking this question this spring, this kind of follow-up reflective question. And this is the pie chart, so I'll flick back. So in this pie chart, see the sliver of green of people who actually got all 3 correct? And see the big half of people who actually got 0 out of 3? Now look at this pie chart right here. The people who actually guessed, yeah, I didn't get any of them correct, is about as much as the people who actually got all 3 correct. And the people who were confident they got all 3 correct, 43%, less than a quarter of those people were right. Safely less than a quarter, right? Even the modesty here is not very modest compared to kind of what happened, right? And here's another way to kind of compare those 2 pie charts, right? So the red bars here, the maroon bars, those are where the amount of people in class and in my spring cohort who guessed, who said, yeah, I did all 3 correct, or I did 2 out of 3 or whatever. So you can see that people were pretty confident, right? Because the vast majority of people picked 2 or 3, but the actual scores, not so good, right? Majority got none correct, safely down on this end of the spectrum here, at least, right? So something's going on, right? System 1 is answering these questions really quickly and really confidently. And if your system 2, which is was semi-involved in this whole quiz, gets any inkling, all it's getting is reports from system 1 saying, yeah, totally handled, everything was fine, we did great, boss, right? And then boss sees like the actual reports and is like, what the hell's going on here? I must be stupid, right? Because I didn't catch it, and so like I must be bad at basic math here. I must be irrational. But that's not quite what's happening. Let me give you another example. I'm going to switch. That's the website. That's the So all I'm going to do is I'm going to play this video for you. If you have done the reading, you might recognize the variety of video that I'm going to show you here. So let's just play along and watch it.
Count how many times the players wearing white passed the ball.
All right.
The correct answer is 16 passes.
Hopefully you got the right answer.
Did you spot the gorilla?
Probably most of you did, right? Because you did the reading and they mentioned this gorilla video in the reading. But if you hadn't, right, about half people, they've done this with a lot of people, about half the people missed the gorilla wandering through the screen here. And if you didn't see it, just rewind this video and you'll see it, and you might be bewildered about how you missed it. And for those of you who are like sitting there a little bit smug, let's keep watching.
For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events.
Okay, so what do we learn from that? We learn that if your system 2 is not active, right, then system 1 is going to go about its business. And if system 1 gets given a task, like counting, right, and lots of times, yes, your system 2 is also involved in that counting, and if we fixate its attention on that counting task, right, then system 1's usual alertness to weird stuff that it reports up the chain to system 2 to tell the boss, the executive boss, hey, look at something, pay attention to this, that it's just not going to do that, right? And so when both of them are paying attention to a particular thing or are busy there, we're actually really poor at recognizing what in other contexts would be totally obvious kinds of things that we would otherwise notice. That's kind of the point here, is this is another way to kind of gently make you feel kind of dumb, right? The quiz did it because like those are obvious answers, but there was some tricks in those questions that kind of distracted, drew the attention of system 2 away, and then exploited system 1's natural kinds of tendencies to lead you to the wrong answers. The same thing happened here, right? We could get the ball passing task to distract people who hadn't ever seen a video like this, so that they didn't notice the gorilla. But also, if you knew that the gorilla was happening, right, then your system 2 was, hey, let's just watch for that. This will be funny, right? And system 1 and system 2 are both directed at that, and because they missed the other 2 changes entirely, even though on watching it again, it's hard to miss that those things are changing. So the question that you might be asking yourself here is, what else is it that I'm not noticing all the time? And why am I not noticing it? And is this not some kind of failure to be, a good brain? Like, is this not a the sign of a fundamentally broken brain? And that if we can do this kind of stuff and break your brain like this, then how much faith can one have in rationality, in thinking straight, in getting to the right conclusions and stuff like that? So it seems like this kind of research that psychologists love breaking brains like this, right? They love finding scenarios where our rationality fails us, right? But they are not concluding that we suck at these things. What they're doing is making more precise kind of judgments, like saying, look, system 1 sucks at this, right? and that system 2 would do just fine, right, if it was activated like we activated when we told you, hey, you missed something, let's rewind, right? Don't pay so much attention to the ball passing or to the gorilla wandering, right? Pay attention to everything. If you direct system 2 like that, then it's easy to see the other changes, right? So you might conclude that system 1 is irrational and that system 2 is more rational. And so if we want to develop our critical thinking skills, we need to rely less on system 1 and more on system 2. That could be a lesson that you draw, and it doesn't sound like a bad lesson to draw, right? Part of the problem is that's going to be difficult to manage, right? Because the kinds of quick thinking, the kinds of snap judgments and jumping to conclusions that system 1 does for us are there for a reason. We don't just have this old, obsolete relic of a thinking system that is just kind of hanging around like an appendix, and that don't think of us as being kind of in an evolutionary stage where, you know, we're 100,000 years out from the invention of a system 2 of a cerebral cortex that does real thinking, and that we're maybe 500,000 years away from just totally getting rid of system 1 or having system 1 become literally like an appendix in the brain that hardly ever gets used. That's not the way things are. System 1 is useful to us right now. It will remain useful to us in the future. It's not going away. But it's there because of evolution, because it was useful to us and still remains useful to us. So when you look at this slide right here, you probably noticed, and it's harder on still pictures like this, be much easier for you to realize that there is a predator hiding in each one of these photos if they weren't still photos, right? If these were videos or real life, even though each one of these predators has coloring and markings that are designed to help it blend into its environment, that's part of their evolutionary adaptation, right? You have super awesome pattern recognition faculties, capabilities built into you, designed to pick those out of that really kind of messy background that they're really trying their hardest to blend into, right? And that's system 1. System 1 is completely responsible for that. And the reason why is because you have been trained through evolutionary history. Your ancestors survived, generally speaking, survived the thicket of predators out there, to childbearing age, to raising people, to raising offspring and things like that, because they tended to be better at recognizing threats like this, right? And so this is kind of the story about how these kinds of adaptations happen, right? So if you have a highly tuned system 1 that overdiagnoses patterns, that is, makes you jump when nothing's there because it just kind of looked like a tiger was hiding in the bushes, but not really, right? So you have a very sensitive system 1, a very sensitive predator recognition thing such that it tends to overreact. Well, if there really is a tiger there, then you appropriately freak out and may survive. If it was just twigs, then you're slightly embarrassed, right? If you have an underreactive, not so good pattern matching, pattern detecting system 1 that isn't so highly developed, right? That it doesn't get alerted all the time, that it prefers not having false alarms, right? And as a consequence, sometimes misses legitimate times when it should alarm. Well, if there's really a tiger hiding in the bush, you're dead meat because you didn't react to it, because you didn't see it, because you didn't detect the pattern of it, right? Now that saves you embarrassment when it was just a pile of twigs, right? But the benefit of saving you of embarrassment, no matter how kind of like in the moment significant the difference is between being embarrassed by flinching about something that's not there versus, you know, being totally kind of relaxed and cool. The difference between these two alternatives here is way huger. This is survival and death, right? Or at least a chance of survival and a significant chance of death, right? And it's repeated exposures to predators, repeated testings of your ancestors' system 1 ability to really react to particular specific patterns, like these ones right here, right? Such that you have been crafted over evolution to have an overreactive pattern recognition system. That's not irrational. That's useful, right? To have that kind of a hair trigger on your tiger alert senses. And so what philosophy does is it asks, well, hold on a second. What do we mean by rational in the first place? We don't exactly mean useful, because that evolutionary pattern there was useful, but also all those false alarms aren't exactly rational, right? Rational is not a synonym for correct or accurate all the time either, because that's a kind of a results-oriented definition, and we would like to be able to say that we act rationally even sometimes when we think wrongly, right? When we end up with the wrong answer, we'd like to say, well, but it was reasonable in the situation I was in with the information I had at hand to conclude X when the truth was Y, right? So rational doesn't exactly mean useful in that it means it gets the right answer, whether that right answer is correct all the time or the correct or the useful answer is you should tend towards overreaction or you should tend towards underreaction for something, right? It doesn't mean as close to accurate as possible all the time, because we'd like to be able to say that just because you ended up at the wrong answer, right? There's different ways to end up at wrong answers, and some are better than other ones. Some methods of getting the wrong answer are totally terrible, right? This is why you get part marks in math class, right? Why your teacher says show your work, because they want to see how you get an answer, and just because you get the right answer doesn't mean that you figured out your math, and just because you've gotten the wrong answer doesn't mean that you suck at math, right? They want to see where things went wrong, or they want to see how you maintained doing things the right way, because process matters, right? In learning math, as it does in learning all sorts of stuff. And philosophers have kind of figured out, hey, when we use the word rational, that's kind of what we mean too. We want to pay attention to the process, not the outcome. And so what philosophers, a general definition of rational is that rational thinking is thinking that conforms to some rules. Well, what kind of rules? Well, it's kind of fuzzy. We're still discussing those things as philosophers. But there's some things that we know, at least ballpark, right? That the rules of thinking that we use when we're being rational are that they're sensitive to evidence, that when you get new evidence, that at least has the potential to change your thinking, to change the beliefs that you end up with, right? So it's thinking that is sensitive to evidence. Dogmatic thinking is not rational thinking. Dogmatic thinking is thinking that is impervious to new evidence, right? So that's not, to be dogmatic is not rational, generally speaking, right? We want rules, not outcomes, but rules that are impartial and are systematically applied, right? So think back to some of the intellectual virtues that we talked about with Paul and with Aristotle, right? These kinds of things are in there too, right? Impartial, intellectual integrity, right? Intellectual perseverance, those kind of qualities, right, are that's another way to say this kind of stuff here too. But in general, the idea here is that what counts as being rational is that we're trying to think up an ideal of thinking that we ought to aspire to, at least in most situations, right? We are probably, even if we come up with a good definition of rational, with all these kinds of things, you think like Spock from Star Trek or some other, Sherlock Holmes in his, non-drug using moments, right? But when he's thinking through a case or something like that, those ideals of rationality where people are insightful and perceptive and can really make clever and good inferences from evidence to something that's correct or nearly correct. Those are good ideals of rationality, but at least in certain circumstances, we're going to say we should be able to say it's rational to be overreactive like this in particular situations, and we should be able to characterize what those situations are, right? We should be able to say, look, a rational individual is generally going to do these things and follow these rules. except for when they find themselves in these kinds of situations. And then in these kinds of situations, it seems more rational, sensible to do other things, to depart from some of those rules, right? And so negotiating what those are, and then getting the psychologists into the game and asking and having them check out how we think and why we think the way we do is the kind of the second half of exploring rationality, right? So in particular, where we have all these tricks that the psychologists can pull about visual illusions and mental illusions and attentional illusions like they did with the gorilla thing or whatever, here's a kind of a demonstration from the philosophical side that's the same kind of thing about attentional blindness, or call it conceptual blindness or conceptual attentional difficulties, right? So this is something that philosophers have recognized for quite a while, which is that what we see, what we perceive of the world, right, depends on the concepts that we know and what we expect to see, right? And so the question I have for you right now is, when you look at this part of the slide that my fake laser pointer is circling, can you look at that without reading it? And can you tell me what you see? Put that stuff in the comments. What do you see when you look at this part of the slide when you're not reading it? Can you even do that? And I would argue that it's going to be difficult, if not impossible, for you to not read what's over here. And that's because you have been raised from a very young age, even if English is your second language. I'm going to guess that most, if not all, the people in this course are people who are either native English speakers or native speakers of a language that uses the same alphabet as English. And so it's going to be really hard for you to not recognize what's over here as letters, if not words, right? So if your first language is not English, and you have you're not super fluent in English, it might be easier for you to kind of look at that and not understand what's there as words, as a question. You might be able to easily kind of slip into a mode of, I can just see letters, right? But unless you are someone who grew up learning a first language that was in a totally different alphabet, say Chinese, Japanese, those kinds of things, right? Then it's going to be really hard for you to see these, to see what's here, just as patches of orange on a dark gray background, right? And it might actually be impossible for you, because the concepts that your brain brings to bear to interpret what's going on here enter in at System 1. And so even if System 2 works hard to try and stop System 1 from doing its business, there's lots of circumstances where it just cannot prevent System 1 from doing what it wants to do, and just kind of has to take it and then maybe try to, with effort, reverse what System 1 did to your perceptions. But even so, that's going to be kind of an approximation, like a forensic reconstruction, right? You can see that stuff as a native English speaker. Yeah, okay, I can see lines, but you kind of got to squint, right? And the instant you relax that effort, the words come back, right? You have to be in a very special circumstances with some very particular kinds of effort to not read the words there, if you're capable of doing it at all. And so that's part of the discussion here, why concepts like rationality is so important to how we interpret the world. And they can, if we have the wrong concepts, they can lead us astray just as effectively as attentional blindness, as System 1 misleading us by paying attention to the wrong things or being primed to see things that are not really there, right? So there's lots of ways in which our brains, which our thinking, can go wrong. The more we know about those and the circumstances in which they kind of manifest, the better equipped we are to compensate for those things. So this is kind of the sum up slide, right? Psychology tells us what we think, right? Ideally, at least. That's what they're investigating, right? And importantly, under what conditions does our modes or types of thinking change, right? When can we rely on brains to work, quote unquote, properly or appropriately? And when can we find circumstances where the training that our brains have been under, either evolutionarily or through learning, entrenching behaviors in System 1, when can we find circumstances where System 1's behavior kind of is inappropriate, but it does those behaviors anyways? And philosophy tells us, or at least seeks to tell us, what ideal thinking is, and also what circumstances we ought to seek it, right? So psychology is going to say, hey, you want to have thinking that's sensitive to evidence, that is systematic, is, deliberate and all these kinds of things, but not, to the exclude. We don't want to argue against having System 1 because there are times when that is perfectly appropriate and good, and so we don't want to have just System 2 operating when we're in an environment where there could be predators around. Now, it is true that in modern life, we don't really have to worry about that. And so what we do have to worry about as critical thinkers in the modern world is understanding all the places where the modern world is significantly and importantly different than the natural world in which our brain has been kind of raised to operate most effectively, right? So we oversee patterns in nature. Okay, that can lead us wrong. We'll talk about that in the last reading. Conspiracy theories, conspiracist thinking is a large part people overdiagnosing patterns that they see in society, in events, things like that. But all sorts of other things that kind of lead us wrong in particular circumstances, right? We literally live in a different environment. We live indoors, straight-walled domiciles, right? Straight-walled houses and things like that. Temperature controlled. Like there's lots of fundamental differences. A day-night cycle, not the same, right? Lots of different things, and those can have unappreciated effects on our System 1, which has been carefully honed to operate for survival in a different environment than the one we spend 95% of our time in. So that could have big effects on our ability to react well, to think well about particular situations. And so we need both. We need both psychology and philosophy working together, or working separately and then meeting up from time to time and sharing notes, right? To figure out how and when to close the gap between ideal thinking and the kind of thinking that we presently are capable of, right? To try and figure out how to best train our minds, how to best retrain or untrain our minds when they do sometimes irrational things to become more rational, and also to realize circumstances where that kind of retraining might be like practically or literally impossible to do. So you realize, look, we can't change the way we think in these particular situations. We're kind of doomed to think irrationally or think unhelpfully in these kind of situations, because then you can start thinking, well, how can we minimize or totally prevent ourselves from entering those kinds of situations in the first place, so that we don't even give an opportunity for our System 1 to do bad things, right? So what's next? What's next is reading number 4, talking about virtues and vices. That's the Paul reading on critical thinking, but I'm also in that companion lecture going to be talking about Aristotle. So have fun with that.